Hi, everyone. My name is Dr. Adam Pennell. I'm at Pepperdine University, and today I will be talking about static balance and some associations of it to some lower body movement outcomes across lifespan age bands. This is for the 2021 NASPSPA virtual conference. As Reed eloquently stated in 1989, measurements of balance or postural control have not regularly or consistently associated with measurements of movement. Not much has changed since 1989, and this has led many to question the role of balance in movement. Yet Reed also went on to suggest that functional action and movement are underpinned by postural control, meaning that while correlational findings have historically been equivocal, it is logical to assume that postural control affords suprapostural tasks and movement. However, much is still unclear in this regard, especially across the lifespan. To help spearhead future investigations, I introduced a guiding conceptual model in 2020, which hypothesized that balance and postural control directly or indirectly influence movement behaviors and/or health outcomes. As this model is hypothetical and novel, investigations examining the proposed relationships are needed. As such, the current study was guided by this framework. The purpose of the study was to investigate for associations between static standing balance and several lower body movement outcomes, specifically endurance and gait speed, across 6 age bands. It was hypothesized that there would be some positive direction, low to moderate, statistically significant relationships between the selected balance and movement variables across the 6 age bands. This was a cross-sectional data set from the NIH. As you can see, a fairly decent sample size with a wide age range, allowing us to delineate 6 specific age bands. So we calculated Pearson correlations between the variables of interest in each of the age bands. So first we have some assessments. For endurance, it was a 2-minute walk test where we got distance. For locomotion, it was gait speed at a usual pace and at a fast pace. So they covered a 4-meter linear distance at a usual or fast pace, where we got speed, meters per second. Then there is the balance component of it. So a lot going on, but in general, there were up to 5 static balance conditions that were completed. All of the balance conditions were ultimately converted into a single item response theory theta value. You can think of theta as similar to a z-score. In the end, that allowed them to give one specific score to represent their overall balance in terms of their performance of balance. So here we have that concept here of the balance theta across the age bands, and this is what we would expect. So ultimately, this figure is showing that balance performance improved with aging, but then started to regress into older age. Here we have some associations, the associations between usual pace, gait speed, and balance performance across age bands. In general, there are lots of nuances and explanations for what could be going on here. However, for the sake of time, I'll only cover the main results. The only hypothesized relationship that was uncovered was in late adulthood, and that was a lower correlation of 0.18. Here we have associations between fast pace, gait speed, and balance performance for each age band. Across the board, the results are more of what we would expect. However, only middle and late adulthood were statistically significant. Still a bit low in terms of correlation. Last, we have associations between endurance and balance performance across the age bands. Now we're talking. So the hypothesized relationships were found in early and middle childhood, as well as middle and late adulthood. Still nothing though in the middle, that sweet spot in the middle in terms of adolescence and early adulthood. But overall, mostly low correlations, except for late adulthood, which reached a more moderate magnitude. So some limitations here, the assessments maybe not the best ever, metrics are a bit limited, it's cross-sectional, and certainly there could be some more high-level advanced analyses of the data set in the future. But overall, we had some differential associations, kind of this hit or miss process here, mostly of low magnitude, but there are some decent clues moving forward concerning the lifespan, especially based on that last visual of the endurance and balance correlations. It may be that associations between balance and movement may be most obvious during early and or late later timeframes in the lifespan, where balance is in general less advanced. That said, many questions remain for adolescence and early adulthood, where arguably balance is most developed and less variable. Harking back to Reed's quotes at the beginning of this presentation, it could be argued that while postural control is nested within movement in a theoretical sense, uncovering such relationships in a linear statistical fashion may be difficult due to numerous systems and their interactions across the lifespan. Therefore, we need more research. That said, when the time comes, I would love to field questions. Thank you for your time.